Finally, here's the program. It's a LabVIEW virtual instrument that will be our digital oscilloscope, okay? Our virtual oscilloscope for this part of the lab. This is how we're going to measure the microphone voltage as a function of time in order to record our results. So this is just a program that samples the analog to digital converter at a rate, number of samples per second that we define. This can run anywhere from 0 to 40,000 samples per second. Okay, that's the highest frequency we need to record. The ADD converter can actually go a little bit faster. And then this is the number of points we'll acquire in each record, which can vary anywhere from a few hundred in this program up to, I think, 10,000. But it's actually just limited by the memory on the computer. And there's another button here called trigger, and we'll investigate what that does in a second. Now let me run the microphone program. I'm going to set it to, we can see what happens if it acquires a set of data. Well, not much happened there. Or we'll have it run over and over again so we can see the microphone signal over time. Oh, excuse me. There we are. So just to prove this works, I can tap the table. Okay. Right now we're taking data at a high rate, but only a few samples per a very small record length. If I made the record length longer, let's change it to a longer value here, and let's also change the X scale to match. Then the signal is more recognizable. So clearly the microphone works, and you can see how the program works as well. I'm going to go back to the setting that we were just using, high sample rate and a short number of points. Okay. And I'm going to further change the graph to show just the first 5 milliseconds of data collection. There we are. Still works. Okay, now let's turn on our source so we can see how that works as well. So we can combine these two parts. So I'm going to turn the function generator signal on. 1 second. There we are. You can hear the pulses whenever the function generator signal switches from high voltage to low voltage or low voltage to high voltage. And if you look, you can see the microphone respond. But right now it's very unsatisfying because these signals occur sort of randomly. What's going on right now is that the computer is just taking data as fast as it possibly can. It's just running over and over and over again. So the data acquisition is not synchronized to the source. But that's not suitable for the experiment we want to do. We need this function generator to be synchronized to the source so that it only starts collecting data when the function generator produces a trigger. That is, when the function generator voltage switches from low to high. Here, that's called triggered acquisition. And I'll engage that now by depressing this button on the program front panel. Very good. So now you can see the microphone signal, and now it appears to be frozen on the screen. Okay, I think I'll just adjust the vertical scale to make that easier to see. There we are. So, just to recap, with trigger off, our measurements aren't very useful because the signal drifts randomly across the screen. We can't do any timing. But with triggered acquisition on, things are much more useful. Now, the signal appears to be stationary on the screen. What's going on is that at 0 seconds, the ADD converter receives the trigger signal from the function generator. and it starts the acquisition. That's approximately also the moment when the speaker produces the pulse. If we look at the microphone signal, there's no signal for some time. There's a dead period here. And then after some time, the pulse reaches the microphone. This dead time, that's just the time it takes for the sound wave to travel from the speaker to the microphone. So we can use this to time or to measure the time of flight of the sound wave. That's how the first experiment will work. All right, well, thanks for your patience. We just wanted to go through the actual physical equipment of the experiment so that you could understand how the experiment works, even though we're doing this remotely. Okay, bye-bye.